Okay, so I made a really dumb error, and I'm going to include it. Welcome to Gridbusters. So today what I want to do is put together another 15 kilowatt hour battery. Now I have a kit from EEL battery and I've got all the battery cells as well. I've got everything laid out here on the desk, ready to go. And let's start putting everything together. So this is what we're going to be building. We're going to be building one of these battery boxes. It's a slightly newer revision. It actually has a circuit breaker on the front panel, which I think is a great idea. Here's the battery case. This is how it comes. I have ordered another one of these trolleys for the battery kit. However, they were out of stock in Europe, so I had to order it from China, and I've been waiting about 3 weeks, and I think it should arrive next week or something like that, but I've got this temporary trolley here, and when we get the new trolley, I'll have to get a couple of people to help me lift this onto the other new trolley, because this ends up being really, really heavy. So the first thing we need to do is install the feet on this case. Right, so the first job we need to do is install the feet. So I was going to turn this upside down. Here we go. So all the parts come in this handy little box here. Now, I couldn't find any instructions online to put this case together. However, there is a kind of video which really just emphasizes the more complex parts of the build, like the front panel. So yeah, sort of figure it out as you go kind of job. So need to make sure I'm using the right screws for the job, and I think those are the right ones. Obviously I don't want to use screws that are too long because I don't want them to poke through the case. I think those are the wrong screws. Let me just see. Yeah. Okay, so I need to find the correct screws to use. I think those are the ones. And there are actually some screws with the feet in the little compartment there with the feet, so I think those are the ones to use. There we go. Look at that. Right. These feet are quite important because, well, I say they're important, but really what they're meant for is so that you can stack two of these batteries on top of each other, because these cases have holes on the top where these feet can slot into. But it's the same with the trolley. So the trolley has 4 holes in it where these feet can actually slot into. And I guess it's to stop the case falling off the trolley. But the thing is, these battery cases are so heavy, and there's not a chance it's going to fall off. But I guess it makes it locate into the correct orientation on the trolley, so you know it's in exactly the right place, I guess, so everything lines up more than anything else. Right, that's the first job done. Next job is let's get the side handles on. These are important because we will need these for lifting the case when when we move this to the other trolley. Right. Right, so the next thing we need to put in is the latch. These, I probably will never use these, because this is if you want to stack these cases 2 or 3 high. I don't think I'm going to actually do that, but I'm still going to put these latches on just because they've given these latches to me and it's part of the case, and who knows what might happen in the future. So that's how they go on, and the idea is if one of these latches is on the bottom case, it basically just secures them together and stops them sliding around. But again, I don't think they would slide around because they're so heavy, but anyway. They're there. Right, so that's the handle and the latch is on. The next thing I'm going to do is take the front plate off, and then we can start assembling the front panel, and we can also get the battery cells in. So let me let's just get that off. and then the front panel should just slide off. There we go. And we can actually, the battery management system and the BMS and everything and connectors all screw to the inside of this case, and then when we're done, we can then just put that on. Okay, so I'm trying a new camera angle today. This is my neck cam, so hopefully the footage comes out okay. So these are the protective sheets I was telling you about. They actually put sticky pads on the back now, so that's a new addition. They didn't have sticky pads on the back of the old on the old battery case, but it worked fine because obviously the batteries hold the sticky pads in place. And oh, okay, it doesn't fit. Oh my gosh. Right, that's not very good, is it? It's slightly too wide. Right, so I'm going to put that one aside. Maybe they're all slightly different. Ah, yes. So, they're not all the same. That was my mistake, user error. So we've got some slightly smaller ones here. These are a slightly different depth to those. So those are the ones we need to use on the bottom. Yeah, so the previous version didn't have sticky pads on the back, which was fine because the batteries hold it in place, but what it did mean was it was more difficult to install because the sheets you put on the side kept wanting to fall over, so it wasn't great. Right, so let's, oh, hang on, this has got also sticky film on it. What's it? Oh, okay, that's just a little bit of plastic there. Let's just think, there we go. Perfect. Right, there we go. Make sure that is the right one here as well. Yeah. Right. There we go. So I guess these ones are for the side. Yeah, there we go. That seems to work quite well actually, with the sticky pads. Big improvement over the previous generation. Yeah, it just makes life easier, stops them. There we go. It's interesting seeing, you know, I've bought, this is the 3rd generation case, and I've bought version 1, 2 and 3 now, and it's very interesting seeing the incremental improvements they make on these things. And it's a lot of YouTubers actually who built these things and made suggestions, and they've actually, this is the cool thing about these Chinese companies, they watch the videos, they watch the YouTube videos from people like me and take on the suggestions. So yeah. There was a lot of criticism originally on this case because the back panel here wasn't solid. It just had a bar on the top and the bar on the bottom, which just basically, you know, it gave uneven pressure on the battery, which wasn't great for it. So they've actually changed it now, so that's great. It hasn't taken that long to change. Right, so we're going to put a couple of these on the back. There we go. There's one there and one there. Okay. And now we can get the cells in. Right, so it's time to put in the first battery cells into the case. Now they do provide these squishy foam pieces which they say you should stick to the cells, and then also have a separator plate between each cell. And you don't necessarily have to use the foam, as I learnt. The previous battery I built, I put the foam on all the batteries, and then with the added thickness of the foam and the separator sheet on each cell, I wasn't able to get the front plate, compression plate on. It made the batteries too big. So yeah, so I'm not going to put these on. And even if you do use these, I don't think you should stick them on because they're really difficult to get off. If you ever want to repurpose these batteries or use them for something else, or if you've made a mistake. So if you do use these squishy foam pieces, I would recommend that you just slip them in like that and not stick them to the actual batteries themselves. I'm not going to use these. I'm going to see how much space is left over once we've got all the cells in. And if there is a lot of space left over, if we don't get any compression on the front compression plate, I will slot in the squishy foam pads. But I will be putting in these isolation separator sheets between each battery cell. So let's get on with it. Right, so on the website they did actually have the correct orientation that the cells are meant to be in, you know, plus minus, etc. So I've just got this as a guide set up over here. So I know that the first negative should be in the top left-hand corner. So let's get that one in there. There we go. And then we're going to put in a separator plate. And then the next cell is going to be positive. Oh, that's fallen over. There we go. And then we just continue that this way. So then the next one is minus. Put in a separator plate. It's not rocket science, it's pretty simple. Pretty heavy though. There we go. Amazing that each one of these cells is 1 kilowatt hour of battery. You know, my car, my Tesla, has 75 kilowatt hour battery. So it has the equivalent of 75 of these in. Wow, pretty crazy. But the price of these cells is coming down all the time. It's unbelievable, really. They're just so, you know, they're almost half the price that they were when I first bought them. So let's see how much space we have. So you can see here, look, that's how much space we have. So there would be absolutely, so this front plate here, this is what's called the compression plate. And these cells will expand over time, and if you put a slight compression on them, it will extend their life. And also it stops them rattling around in the case. So unlike the first case I built, it looks like there is going to be enough space to put in the foam inserts. So let's give that a go. So we've got, so let's see how many of these we can get in actually. Excellent. So it looks like we're going to have enough space, I think. I think what I will do is I will take off this front panel here. Perfect. I think EEL battery must have seen my previous video where I was struggling with this, because when I did this originally on battery case version 1, with all of those pads in, it was right out here and you couldn't actually get the screw in, but with that we're going to get a little bit of compression there, so I think we're good to go with that, so that's great. So I'll leave those off there and let's get the other batteries in. So these are the battery balancing boards which go onto the battery. And let's just quickly talk about balancing, because it's something that confused me when I first got into battery building. And let me just explain what I mean by balancing. So in a battery pack like this, we have multiple 1 kilowatt hour cells. In fact, we have 16 of those, because it's a 16 kilowatt hour battery. And it's very important that every single battery cell remains the same voltage. And if they start being different voltages, you can actually lose a lot of capacity in the battery. So as an example, let's say one of the battery cells was at 100%, and let's say all of the rest of the batteries were at only 80% or 80% charged. Well, what the actual balancer, the battery BMS does is it protects the battery and stops the battery self-destructing and destroying itself by stopping the charge when the battery gets to 100%. So what it will actually what it actually does is it stops charging when the first cell hits 100%. So what would actually happen in that scenario is when that first battery cell reached 100%, it would stop charging, even though all of the other 15 batteries were at 80%. And if that were to happen, we would actually then end up losing 20% capacity of the batteries. So it's very important that the cells all remain at the same voltage. It can also cause other problems as well, particularly when the battery is at the other end of the spectrum, is very empty. So it's important that we keep all of the cells at the same voltage. And the BMS, what this BMS is supposed to do is it is supposed to what's called balance the battery by having individual cables connected to the BMS board to every single cell of the battery. And what it will do is, in a scenario like we just talked about, it would actually be taking voltage from that 100% capacity battery and moving it, so discharging that cell and putting it into the other batteries. And that's what this board is for. So these boards actually connect with a multi-pin cable to the BMS, and then all of these wires connect to all of the cells. And that way, if the cells are out of balance, it's pulling power out of one battery cell and putting it into another battery cell. And that's what balancing actually is. So that's what these connectors are for. I mean, technically, you could just have a bunch of wires going from the BMS itself and sort of manually connected to the cells. But EEL battery, they just make things simple by just providing a multi-pin, it's actually two multi-pin connectors to connect to each one of these boards here, and then to the BMS itself. It just keeps everything neat. And that's how things should work in the perfect world. Now, the problem that we've been running into with the surplus BMS, and in fact, most BMSs on the market, some of the very, very new BMSs from JK BMS seems to have solved this issue, but the ampage that the batteries are actually being balanced at has always been historically too low. So these BMSs just can't keep up with these big battery packs. And as a result, what has actually happened traditionally is the battery has ended up being slightly unbalanced because these BMSs just can't quite do the job. And I don't know why Surplus hasn't addressed this, but other battery balancing, other battery BMSs have addressed this now. The JK BMS has, it's a different brand of BMS that has come out, and that has solved the issue. And a lot of people have asked me, why have I just not switched to the JK BMS? Well, that is because I would have to change all my other batteries or get an interface board because the communication would be different, and I've got a solution that works at the moment. So let me explain. So EEL battery, the battery case box people, they've thought about this, and what they've actually done is when you buy a box from them, they include the BMS, but they also include an extra smart balancing unit. So this is the best balancer on the market. It's the Knee Active Balancer, NEEY. Normally these cost about $70 each, but if you buy a kit from EEL Battery, they actually include this with the kit, which is fantastic. So it's a standalone balancer, and it works incredibly well. I've got them in the other batteries, and I've logged in. You can log in through an app actually and have a look, and all the batteries are perfectly balanced after months and months of use, which is great. Now the only downside to this is I think eventually what will happen is they will have a multi-pin cable which connects to these boards, but right now you can't actually do that. I think it was an oversight when they designed these boards. These boards can't actually handle the current that the knee active balancer gives out. So they provide you, so this brings it into the realm of like really serious DIY, I think, where they provide you with the multi-pin cable, which is great, which plugs in here. But as you can see, there's nowhere, it's just like soldered ends on these cables. So this is the only kind of thing which is slightly more difficult to do with this battery kit. And it is absolutely critical that you get these wires connected up to the battery cells in the correct order, because if you get it wrong, you'll destroy the balancer. So it's really, really important. Now they do provide a wiring diagram, and I will show how I connect this up when we get to that stage in the battery build. But just a really quick thing, what I've actually been doing is, let me just turn the screen on the camera, can we see? There we go. So what I've actually been doing is I've been going through and labeling every single cable on this wiring loom. So you can see I've got these little, there you go, they just slide over, they're like little numbers, they just slide over the cable there. And this just ensures that I get this absolutely correct. So in the wiring diagram, it was quite simple actually. They just showed that the first cable was number 1, then it was number 2, then number 3. So I've actually just put the numbers actually on the cables themselves, and that means that when I connect it up, I know that the number 1 cable goes to battery cell number 1, etc. 2, 3, 4, 5. So that's what I've done just to make life a little bit easier. The other thing I'm going to do is I'm going to be cutting all of these cables to exactly the correct length, because they're all the same length. And obviously it's quite a big battery case, and the cell at the front of the case will only need, a very, very short cable, but the cell at the back of the case will need a long cable. I didn't want to have lots of cable all scrunched up and messy in the front, so I'm going to cut every single cable to exactly the correct length, get them all connected up, and then we'll cable tie everything to make everything neat. So the cables, the balancing cables, will just be a wiring loom which will go in between these 2 balancing boards. So that's what we're going to be doing. So it's a little bit fiddly, and we also have to crimp ring terminals on the end of these cables. I'll be crimping them and soldering them just to make doubly sure. So that's just a little word about balancers and what the heck it is, because I know what it's like when you first, a lot of people will know exactly what I'm talking about, but when I first started watching these videos of people putting batteries together, they would just talk about the balancer or talk about the BMS, and I didn't know what a BMS was, I didn't know what balancing was, so I just wanted to explain it just in case you weren't quite sure. So the first thing we're going to do is we are going to install these. And let's just see, so this one has already got foam on the underside, and we need to just install some of this squishy foam here. So there we go. So it's just, this has got sticky back as well, so we can just undo it there, and there we go. Doesn't have to be 100% accurate, but so just to make it non-conductive. Great. Okay, so the next thing I'm going to do is, I don't know if you've seen the previous video, but in the previous video we had a problem with one of these boards in the other battery, and that was we had a crack in the board, and it is a slight design fault because there are screws which hold this board in. However, at the very end where the connector is, there are no screws, so it's very easy to bend the board when pushing the connector in, because it pushes in from the top. So not a great design. Let me show you. So you can see here, I've only got 1 screw in at the moment actually, but there's no screws at the end, no standoffs at the end, and you can see it's like slightly wobbly there. And if I was to put that connector in there, it would actually bend the board, which is not great. So I could hold it underneath, I'm not sure. So what I'm going to do is I'm going to remove this from this housing and put it flat on the table, connect in these connectors, and then screw these back, just to be doubly sure we don't crack another board. Right, so let's get this first board out. So I'm going to put my hand underneath. Can you see that? I think you can, just about. So I'm being just extra cautious because I have damaged one of these in the past. I mean, maybe it came damaged from the factory, I don't know, but yeah. So there we go. So I think they need a redesign on these. I think they need to redesign it anyway because it needs to carry a little bit more current so that the let me just show you. So the crazy thing is, you know, the BMS plugs in here, and there is actually a socket here for the balancer, and I think that is how they originally intended the thing to work. But they actually say in big red letters, do not connect your balancer up to this socket, even though, you know, the balancer doesn't come with a multi-pin socket, but I'm sure some people have soldered one on and used that. But they say this board doesn't have the capacity for a balancer. So I'm guessing that the battery manufacturers had, like, you know, 50,000 of these boards printed up or something, and that's why they're just trying to use the stock. And once the stock is used up, I guess they'll have a revision too, which will have the capacity for the balancer, and maybe they'll have some extra standoffs on here so that you don't crack the board when you plug the cable in. I think that might be a better design. So yeah, just a suggestion, just a small suggestion from me. Right, time to install these. They are actually labelled 2A and 2B on the board. So 2A goes on the left, and there are screw holes down here and at the back as well. So first thing I'm going to do is I'm going to put my, I have to be very careful now because everything is live. So I'm going to put these down here. There we go. The thing with these screws is you don't want to do them up all the way. I like to get them in about halfway. I'm going to back that one off, just so we still have a little bit of wiggle room there, so in case the back one doesn't quite line up. And then when I've got the back screws in, then we can get everything tightened up. So the next job is to connect up all of the bus bars. They've provided these nice flexible bus bars. They also have a thread insert there for the balancing cables. So the first thing we're going to do is start just placing these bus bars in place, just to make sure we have enough and everything fits. So hopefully we're all right. Right, there we go. So okay, that one has two. Okay, I'll have to look at that. There's two. We've got two balancing cables on that one, so I'm not quite sure. There we go. Go there. Yep, that's good. Whoa, something's going on here. Okay, so we've got a serious problem here. Okay, so I made a really dumb error, and I'm going to include it. Now I do have this actual diagram here from the previous battery. So in the old batteries, they used to provide a manual. They don't on this battery. So I'd recommend that you look on there. There is a PDF online which has this diagram of the bus bar layout. So yeah, I was actually connecting up the bus bars the wrong way. Blimey, I hope I haven't damaged the battery. It's still reading the same voltage and everything, so we should be okay. Yeah. Oh, so dumb. Right, okay. I guess it will make good YouTube though, won't it? Right, so I'm just following the diagram here religiously now. So there we go. And like I was saying, some of these do have 2 screw holes. So, right, so where are we? So we've got this one here, and then this one goes. It's like a snake pattern. So we just want this single, and then we've got a single one here. Right, okay. I think we're there now. And I won't connect the final one here because at the moment we've got 2 24-volt batteries, which is quite safe. As soon as we connect that, we've got a 48-volt battery, and that really increases the voltage. So I won't connect that up until I've got everything else connected. But yeah, so good thing I had my little diagram here. I should have been following that. That was just a dumb, stupid mistake. Yeah, there we go. So we've got a. Hopefully those those cells are okay. They seem to be pretty resilient, so I'm hoping that will be okay. But yeah, just watch where you put your bus bars. Right, one more quick job before we do the front panel. We just need to secure these bus bars with some bolts here. So again, the instructions are a little bit vague for the torque setting. It says between 6 and 7 Newton meters. So I'm going to split the difference, and I think I'm going to do 6.5. So I've put 6.5 in here, and let's tighten these all up to 6.5. So I contacted EEL Battery, and they provided me a link to a PDF document. So I've got it on my laptop here, so I'm now following along. So there is a PDF document available which you can download, but they should include like at least a little note in the box or something telling you, or a QR code to scan to get the manual. Nothing like that, but little things that they should do. So anyway, so the first thing we're going to do today is, or rather, it's the same day. I've just had lunch. That's all. We're going to screw these in. So I just need to make sure that these terminals are facing this, in that orientation there. So that's important. So let's get those in. I have to say, if you're doing a case like this, there are an awful lot of nuts and bolts and screws and things to put in, and having a little power screwdriver like this makes all the difference. So I definitely recommend getting one. I think this was only like 35, 40 euros or something, but it's, you wouldn't want to use it for construction or something, but for electronics, brilliant. So if you're putting something together which is going to require a ton of bolts putting in, definitely worth getting one of these. I don't use it for everything, but where you've got lots and lots of fasteners to attach one after another, it saves a lot of time and a lot of effort as well, so I definitely recommend it. This Bosch one, really good. Just get, you don't have to get the Bosch one, get whatever's on sale. The reason I liked this one was because it has a USB socket on the back, so I can charge it using a phone charger. So that's always good. Wouldn't want to put AA batteries in there or have some weird charger. The fact that I can use my phone charger, that's pretty good. So there we go. So there's only one set of terminals on here for this particular type of battery. So, right, so the next thing we're going to do is we're going to put in the screen, which is here. So the first thing we need to do is pull off the plastic cover. There we go. Really important you do that first. First time I built one of these batteries, I didn't peel the screen. I thought, oh, I'll leave the protective cover on until the battery is complete, and then I realized I couldn't pull it off. So yeah, you really want to make sure you've got that done first. There we go. So that goes in here. So I just need some small, I'm going to use my magnetic screwdriver for this. There we go. Picked up a load of screws. So sometimes the electric screwdriver is the wrong tool for the job, and sometimes the magnetic smaller screwdriver is better for these delicate things. Oh, and I've already made a mistake, so we need to put in, there we go, mistakes and all with this video. I hate seeing YouTube videos where everyone just appears perfect. So what we need to do is, let's just get all of this out here. Here we go. So we've got these little buttons. So we need to attach, there we go, not sure if you can see that, these little buttons. Again, the first time I built one of these batteries, I screwed this all in and realised the buttons felt weird. And that was because I hadn't put the plastic clips on. There we go. So that should now go in. Okay. Let's get that redone. This particular battery case is slightly different to the other two battery cases I've done. And the other two battery cases I did like a year ago, so it's quite a long time ago. But this battery case is different because it actually has a circuit breaker. So here we go, which is actually quite a cool feature because you can actually use it to turn off your battery, you know, physical switch, as well as being a breaker. So that's pretty cool. I mean, obviously I've got my circuit breakers on the wall and I prefer those because it's a shut-off switch that turns off the neutral and the live. But having this included with the battery, I think that's you know, that's pretty good. So I'm happy with that. I think that's a good improvement over the last battery. So I'm guessing that this just goes over. That's not lining up. Okay, so maybe that goes around that way. Yeah, that's better. And then we've got a cover here which goes over the whole thing, which is sort of sandwiched, and the screw threads are in the cover. So it's a little job of lining everything up and then finding a screw that's going to fit. And it doesn't look like I've got any left that will fit. So, gosh. Right, so I found it. It was this little packet of screws here, which I'd actually put to one side. I didn't realise this was from the battery build. So, yeah. The one criticism I've had with these cases all along, even when you have instructions, is they don't tell you which bolts are for what. I mean, in the instructions it was like, say, use the M3 bolts for this or the M1 bolts for this, but they don't actually tell you in the box which ones are M1, which ones are M3, etc. So yeah. But yeah, so this is, I've got 4 little bolts here, and then there's a screw, like a screw thing here to screw the flap down. Just for the front of this, you can just screw that shut. So yeah, got those. Right, let's get that in then. And I think the bus bar is going to go in, yeah, it's going to go in here, but I can't see how you tighten this up. Ah, okay, so I think I need to take this off. There we go. So there are instructions, but the instructions are a little bit vague, I have to say. Let's just have another look at this circuit breaker. I think there might be a screw on the front of this where you have to screw the bus bar in. Yeah. So let me just grab a bus bar and show you. So with these connectors, we've got the bus bar, and the bus bar is going to go into that hole there, but then you have to tighten it with a bolt on the front there, which is going to be up against the front plate here. So I guess you have to put in the bus bars first. Okay. Ah, right. A little bit complicated. Right, so from what I can make out, that is the way that the circuit breaker should be connected. So let's just do this top one here first. There's no torque spec for these, but I think I'll just use common sense. Right, there we go. And then this one will go in here. Now these are flexible bus bars, so these joints here will and can move. So let's get these done up as tight as I can. There we go. Okay, so let's get the on-off switch connected. Okay. And then the BMS itself. So we're going to line up these sockets here and this dip switch and these LEDs with the holes that are on the front there. Okay. Again, I think these are the right screws, but I'm not 100% sure. I think, yes, they seem to fit. Right, we'll use these ones. They're good enough. Again, I'm using the hand screwdriver on this because it's a circuit board and I don't want to do these up too tight. It's a little bit delicate. Okay, so that now goes to there, and this one connects to the screen, which is also the Bluetooth module. Perfect. And then this one is supposed to line up with this, and it doesn't line up. Ah! Oh dear. This isn't very good, is it? So we have a problem. Ah. So this is the first time I've had a problem with the EEL battery, and yeah, this is not good. This doesn't fit. Answers on a postcard, please. See how well the other ones fit. Well, let's connect these other ones up first. Right. No, it's not even close, is it? Unless it's... I mean, that would be about as far over as it would go. Unless, did I put this in upside down? No, I don't think I did. Let's have a look. No, that's incorrect. So, yeah, that's in the correct way. Actually, no, hang on a minute. I have put it in the wrong way around. Right. Okay, the plot thickens. So it's a user error. So it goes in. Let me just double check this again. Goes in like that. Yes, that's correct. Right, there we go. Right. Okay, so we now know. I wanted to show you guys the mistakes as well, because it can be frustrating when you see people doing things and they just sort of do it the first time and cut out all the mistakes. There we go. So that's pretty much perfect there. I think it goes like that. There we go. Right. I'm looking at the picture on the computer screen, and I think it goes that way around. So, and then if we look at it this way round, we can see the writing is the correct way up there. So we know that is the right way, and that's going to go on there like that. So let's get that now screwed in. We're getting there slowly. It's going to be tight. It will fit with a bit of persuasion, shall we say. There we go. Oh, wow. Notice I can't get a socket in there. So, okay, well, we'll just have to get a bigger screwdriver. Okay. There we go. Okay. So the first thing we're going to do is connect up the balance cables, even though they're not actually connected up to the main board yet. So just going to connect this up. There we go. That's that one. And that one. Just hand tighten these for now. And the pack is not live yet because, well, we've got two 24-volt batteries, but we haven't bridged the connection there at the back, so nothing is properly connected. So right, those are definitely not torqued. So this is the knee active balancer. This is going to slot in the front there behind the cable. So I will be removing this plate again and just slotting it down in between. It used to come with a metal bracket to hold it in, but they no longer supply that. I don't know why, or if they just left it out on my case. But I think I'll just hold this in place on the inside with a piece of double-sided tape. I think that will hold it absolutely fine. That shouldn't be an issue really. So yeah, that will slot in there, and then these cables will go down here and bridge off to each of the individual battery cells. Now I want to cut these wires so that they are exactly at the right length. So I think what I'm going to do is first of all, let's just separate these out, because this is the first bunch of cables here. I want to give myself a little bit of slack. I don't want them too short. And we need to start with cable number 1. So I actually have labelled these all up. So that's cable 2 and 3. Let's find cable 1. Here we go, the black one, that's cable 1. Connect around there. I'm actually making these slightly longer than they need to be. So push my numbers down so they don't fall off. Those are all the correct length now. So that's 8. So now we need 9. Again, that's going to be the correct length there. 10. 8, 9, 10. Okay, we'll take a little bit off that one maybe. 15. Right, so the next thing we need to do is to strip these back and crimp on these ring terminals. Not sure if you can see that. So what I'm going to do is strip back all the cables, tin them all with some solder. I'm going to crimp them and solder them as well, simply because I've had an issue once where I've crimped these on and it hasn't been a great connection. So I think if I crimp it and solder it, then I'll be like doubly sure. So yeah, I think that's what I will do. We'll just see how that will work. If I put that through there, yeah, that should work. Then I can solder them and crimp them as well. Right, so let's get to crimping, or rather stripping cable back first. So I'm just gonna, let's get the measurement right on this. So I want to go to about there. Okay. And let's get these cables installed. So we need the first, let's get these all in place. So, okay. So this is for battery number 1, which goes over here. So it's going to go through there. We've got both of the balance cables on here. And right, so there we go. We've got the little number 1 on there. So that's both of the balance leads. So now I just need to connect up all of the rest of the cables whilst keeping everything neat. Time to get the lid on. Okay. We're getting close. Almost there. That's the battery together. I've done all the programming on the computer. What I've done is I've copied all the settings over from battery number 1 to battery number 2. That's one of the great things about the Surplus BMS. You can just go in to the settings on one of your batteries, save all the settings to a file, and then load that into the other battery. So that's all done. The knee active balancer, done the same thing. In fact, the knee has only got like about 4 or 5 settings to do, so I literally just manually copied those across, labeled it as battery number 3. So that's all done, all working. The final thing to do is to connect up the battery to my switch here and then hook it up to the bus bar. So the first thing I do is just hook up the negative cable here. I will torque these up in a second once I've actually got the cables in. There we go, that's good enough. So the final thing is to hook up the cable from the switch here to the bus bar. I've only crimped one end of these connectors and I haven't crimped the other end because I'm not sure which orientation the ring terminal needs to be in. So let's get that sorted now and then I can get those crimped. So the first thing is let's just get this cover removed. Let's see where we're actually going to put this battery, where we're going to connect it to. So at the moment the Turbo GX is actually connected to here, which is a little bit of a waste of a port really. I could connect it somewhere else and I may do later on, but for now it's fine there. So I'm going to connect the battery to this terminal here. So let's get that done. So the first one I'm going to do is the black cable. So actually before I even do that, let's get these bolts out. Right, so I'm happy with that. So what I'm actually doing is I'm just putting a magic mark on the connector and on the actual cable, so I know the correct orientation to crimp those. Now these cables are a little bit long now because it's actually closer, and I don't want to cut it shorter. It's important to keep all these cables the same length, or what can actually happen is one of your batteries will end up charging quicker than the other battery, which is kind of like why this is a little bit longer than it needs to be. It's not too bad. So let's do the same with the other one. So I guess that's gonna come here like this, and then it will go down there. Right, happy with that. So let's just get a mark on there. So that's in effect all I'm doing, is just so that otherwise when I get the cable here, the ring terminal might be on its side, and then I'd have to like physically twist the cable around and put strain on it, and that way we get it at exactly the right place. So I'm going to quickly just nip off to the workshop and get those crimped. Not going to film that. I've got loads and loads of videos on crimping. If you want to see a crimping video, go back to an earlier video. But yeah, I'm just going to get those cables crimped up in the workshop, and I'll be back and then we'll fit those. Everything fits just about. Whew, it's hot in here. Okay, time for the big power on. So I've connected the batteries, everything's torqued up. I've connected my communication cable. I've changed the dip switch settings. So everything's now in parallel. So first thing we're going to do is turn on the isolator here. And then let's turn on the screen. Excellent. So we've got about 50% battery. That's usually how they come from the factory. And all the other batteries are online. We haven't turned on. Let's just have a look. So at the moment we've actually got 48 volts on the battery. It's very early in the morning. It's about 7 a.m. here. So we haven't got much voltage on the solar panels yet. But let's do the big turn on and see what happens. Ooh. Okay. So I'm hoping, I think that's it. I think we are live. So I've just gone to the settings here on the touch screen, and we can see battery modules 3 online. So we've got a little warning there That's just because I haven't cleared that warning yet. That was just because I had unplugged one of the CAN cables. So the system was worried that that's why we had a warning there. But there we go. So everything is now live. Well, that's it for today. Thank you so much for watching. If you are still watching, very, very long video there. Lots of ups and downs, and thank you so much for everybody who has subscribed. Now, if you haven't subscribed, please do subscribe. It really does help me out, helps the channel out, gets me to make more videos like this. And I'd really appreciate your comments and suggestions in the comment box. Okay, guys, we're going to leave it there, and I'll catch you next time.